Hello everyone, welcome back again. So as you know that we have started a B.Sc Mathematics series, and I have already told you that in the very first lecture or in the very beginning I will start from the group theory. So today is the day where we learn about group theory. But before directly jumping into the group theory portions, we have to know some basic informations, okay, that we have to know, okay, before starting group theory. So you already did it in class 12, but still I'm just doing it because it is necessary, okay. And I'm assuming that I'm assuming that you know the set theory concept, mapping and relations, whatever the thing is, okay, because these are the very basic things that you today we'll learn about important concept that is called binary compositions. I'm very uncomfortable, okay. Let's see. Okay, so this is a binary composition. We will learn binary composition. Okay, so basically, what do you mean by binary composition? Let's suppose let A be a set A which is not equal to 5, means A be a non-empty. Okay, A be a set. Okay, and binary composition is what? A mapping F which is defining from A cross A to A. You should know, or I mean, do you know that what is A cross A? I think you should know. A cross A is your Cartesian product. Okay. When you learned about relations, the before relation, you learn about Cartesian product, right? So this is a mapping. The binary composition is nothing but a mapping which is defining from A cross A to A. Now, what does it mean? Now, first tell me, note elements of A cross A, elements of A cross A looks like something A comma B type. Okay, A comma B type का pair आएगा ना, because it is from A cross A. Okay, so first element is from A and second element is also from A because it's A cross A set. Okay, and in this set A, it looks like some C type of element. So binary composition means if we considering A comma B, okay, A comma B pair, so its image under F will go to A. Okay, and since I didn't define any definition that how it goes to A, okay, in which relation or in which format it will go to A, so I didn't do anything over here, but it is very confirmed that image of A comma B will go into the set A. Okay, so how it looks like basically, if we give an example, let's suppose this is your A cross A set and this is your A set, right? This is your A cross A and this is your set, and you're defining a map that is called F. And we know that if a set has cardinality n, then how many, what is the cardinality of A cross A? Say that is n square. It's very obvious. Okay, n square. Yeah, let's say like if you have said set A consisting 3 elements, then what is its cardinality of A cross A? That is 9. Obviously, that is n square. So here is your n square element. Okay, here is your 1, 2, 3, 4 up to n square elements, and here is your n elements. Okay, so it means now mapping means all the elements of A cross A is connected to some elements of A. It doesn't require that all the elements of A cross A should be connected to all the elements of A. It is not required in the mapping. Okay, so it's basically connected A cross A. All the elements of A cross A should be connected to some of elements of A. Okay, now let's jump into the example because it will clear your doubts very clearly. Example. For example, if you take the set of natural number, like if you take A equals to n, okay, and we define what we define like how it goes. Okay, that is A. Acha, very first thing, before doing this, let me do one thing, that notations. Okay, let me clear your notations, and that how we define notations. Notations means, like, here we write f of a comma b goes to a, so we can write this as a comma b. It means we can write as a compose b. Okay, this is called compose or binary composition. Okay, now if we define something like how a compose b looks like, it means what is the image of f of a comma b. Okay, that is we defining. That is a compose b. Let's suppose we are defining something like a plus b, or something like a into b, or something like ab minus 1. Let's suppose, okay, if just composition is defining something with these two elements. Okay, and you know all the arithmetic operators and something. So that's how we're defining. So now we can say that how f of a comma b looks like. Okay, so now let's jump into the questions. A equals to natural number, and we define a compose b as a plus b. So you have to check that under this composition, this forms a binary composition or not. Okay, I mean, under this operation, this forms a binary composition or not. Okay, so let's check. Okay, so a and b, both a and b belongs to a natural set. So what we have to show, that f of a comma b, that is here is your a composition b, also belongs to your natural number, that is set a. This is the definition, that all the elements of a cross a, okay, image of all the elements of a cross a goes to the elements of a, okay, the set a. So as we define a compose b as a plus b, so it's very much pretty sure that if you take any elements a and b from natural number, then after adding a plus b, it surely goes into natural number. Like if you take a as 1 and b as 2, okay, so after adding it, it will give you 3, and 3 is already in natural number. So it is always true that for any ab belongs to natural number, for any ab belongs to natural number, your a composition b means your a plus b is also in natural number. So, and this is true for all ab, this is true for all ab. So it means this composition, or this basically this circle, okay, this o forms a binary composition. So you have to just check that for all ab belongs to, I mean, note, okay, that how you check, you have to check for all ab belongs to the set a, your a compose b, or that is your f of ab, belongs to that set or not. You have to just check for all ab, that I already mentioned, that for all elements of a cross a, these all elements should be connected to some of elements of this. Okay, wait, you have to just check that all elements of a cross a should be connected to some elements of a. So here for all ab belongs to a, okay, I mean for all ab belongs to a comma b belongs to a cross a, you have to just check a compose b belongs to a or not. Okay, let us take another example. Example 2. Okay, let's take a as let's say, let's say another example of natural number. Okay, let a is equal to natural number, and now we're defining a compose b as a minus b. Okay, as a minus b. So now you tell me, that is this a binary composition or not? I mean, this operation forms a binary composition or not? Just think about a little bit. You have to check that for all a comma b belongs to a cross a, does it imply that a compose b belongs to a, I mean belongs to natural number? You have to just check it, right? So if you think about, let's suppose you take a equals to 3 and b equals to 2, then what will be the a compose be? That is 3 minus 2. 3 minus 2 means 1, and that is already in your natural number. So can you conclude that it forms a binary composition? No, because you have just checked a particular, particular element. You have to check for all elements. So if anyone finds another some a comma b, another pair, for that a compose b doesn't belong to natural number, so it means this operation cannot form a binary composition, right? Okay, so now if you take, and since it is a minus b, okay, so if you take a as 2 and b as 3, just reverse it. Okay, so what will be your a compose b? That is 2 minus 3, and 2 minus 3 is minus 1, which doesn't belongs to the set of natural number. My handwriting is so bad, my okay, so minus 1 is doesn't belong to natural number. That's very obvious, because minus 1 is in integer set. Okay, so what does it mean? It means a compose b under the set natural number doesn't form the binary composition. That's very obvious. BC, I mean, it's not about BC, it's means something else. So let me a finally binary composition. Okay, binary composition, because I am very lazy to write something. Okay, so it means it is not final form of binary composition. But if you change the set, okay, let's say if you change the set to z, that is set of integers, and if you define the same operation as a minus b, now under this set, this operation forms a binary composition. Just check it. Okay, check it by your own. Let's suppose if you take another example, a equals to z, and if we defining a compose b as, let's suppose, a divide by b. Okay, a divide by b. So can you tell me that this forms a binary composition or not? Just can you tell me that this compose a binary composition or not? You have to just you can take any example, because if you choose a equals to 1 and b equals to 2, so after doing a compose b, that is a by b, that is 1 by 2, that is not in z. Very much obvious. And it's also very much obvious if you take a belongs to any z. If you take a belongs to any z element and just b as 0, so a compose b is equal to a upon 0. That is not in the set z. Okay, that is undefined. So it means this is not a binary composition. Not a binary composition. It's very easy. Okay, wait a second, I'm recording or not? Wait a second, just a minute. Okay, I'm recording. But yeah, I'm recording. I thought that I stopped recording. Okay, fine. So this is not a binary composition. But again, if you set if you change the set a to natural number, or if you do the same thing, a by b, so you will check that this also not a binary composition. Same thing. Okay, but if you change the set to real number, then also this thing forms a not a binary composition. Why? Because see, when you choose the set real number and you will just doing a compose b as a upon b, so if you think that you can take a belongs to real number minus 0, let's simplify it very simply. Okay, not doing these things. Let's suppose if you take a equals to 1 and b equals to, let's suppose, 2.5, because this is a real number, you can take it. So what will be your a by b? That is 1 by 2.5. That is something you will get 1 by 2.5. So it is a real number, so it belongs to real r. Very obvious. So if you take any real number, you will got a by b real number. But for the one case, like if you take any real number, a belongs to real number, no worries, no restrictions. But if you choose b as 0, because 0 is also real number, so you know what is here a by b, that is a upon 0, that is not in R, that is in undefined. Okay, so it means this will also not a binary composition. So what restricted this a compose b equals to a by b? On we see that these a by b not form a binary composition on the set Z. These a by b also not form a binary composition on R. These a by b also doesn't form a binary composition in the set R. So what restricted this a by b to not form a binary composition? That is the denominator part. Because until and unless you restricted the denominator, it will never give a binary composition, because we can take 0 then. So what we can do, if you can change the set a to real number except the 0 element, okay, I mean 0 element, except the 0 element, then under this set your this composition always give a binary composition, always forms a binary composition, because then you don't have to take these conditions, okay, to check it. So that's how you can check that whether it forms a binary composition or not, depending on the set, not depending on the definitions that how a compose b is formed. It is a by b, a to the power b, log a plus log b, whatever the thing is, that is not the important. The important is the set, that in which set it is binary, it forms a binary composition, and which set it doesn't. So you have to be very careful about the set, okay, that in which set we are talking about these things. So today's lecture is very small, because we don't do a lengthy lectures. So today we just learn about what is binary composition, and we just see some few examples. So in the next video we will do some properties of binary compositions, the it is in commutative or associative or whatever the things is. So we'll do in the next class, and after the next class we'll just start group theory, and like main group theory, the main concept of groupoid, semi group, and whatever the thing is, monoid, something वगैरह वगैरह. So that's it for today. So मिलते हैं next video पे. Nothing to say about it. So try करते रहिए. All the very best.